Hi everyone, John here again from the Efficiency and Reliability Podcast. In this episode, we explore how IGS Technology Solutions tackled corrosion and erosion challenges in a US-based copper complex by implementing advanced cladding solutions to significantly reduce maintenance costs and extend equipment lifespan. US-based copper complex with similar operations to Codelco Chuquicamata's uses waste heat boilers to recapture heat from its copper flash smelters via the FS flue gas stream. This increases facility efficiency and can lower operating costs. However, the flue gas streams contain sulfur dioxide and other sulfur compounds, salts and metal oxides or ash, which leads to corrosion, erosion, and accretion buildup in the waste heat boilers. To protect the WHB water walls from corrosion and wastage, the copper smelter plant installed a different coating from another supplier, not IGS, in 2012 and 2014. This coating provided some protection, but showed evidence of cracking and spalling in some areas. To ascertain the condition of the coating, a sample of the previously installed coating was sent to IGS Technology Solutions Laboratory for a metallurgical and corrosion analysis. Cross-sectional analysis via SEMEDS revealed extensive media penetration, a high coating thickness and insufficient chromium content without deoxidation fluxes led to excessive oxidation, porosity, and cracking in the coating microstructure. Sulfur species penetrated through the bulk of the coating along the porosity and cracking. To prevent cracking and porosity and extend the lifetime of the applied high-velocity thermal spray coating, it was recommended to use a high chromium alloy modified HVTS wire such as IGS 5450 and IGS 5470 to limit oxidation and cracking during application and prevent the formation of corrosive media pathways.